A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So let's first draw the diagram. So let's say this BC is the highway. Okay. And initially, let's say the car is over here. And this is traveling in this direction. So after 6 seconds, the car is found to be in this point. Now, a person is standing over here on the top of the tower. So from this point, the angle of depression of the car initially was found out to be 30 degrees. After 6 seconds, when the car reached over here, the angle of depression was found out to be 60 degrees. Now, as these two lines are parallel, if this is 30 degrees, then this should also be 30 degrees. Similarly, if this is 60 degrees, this should also be 60 degrees. Now, let's assume the speed of the car is equal to some s, or let's take it to be u. Okay, let the speed be u. So, you know that distance is equal to speed into time, right? Because speed is equal to time into distance, distance is equal to speed into time. This is the basic formula. So from this CD, so this distance CD, how much will CD be? CD is nothing but the distance car traveled in 6 seconds, because in 6 seconds the car moved from here to here. Therefore CD will be speed. Speed is nothing but u into time is 6. Therefore CD will be 6u. So this CD is nothing but 6u. Let's assume the height of this tower to be some h. Now they asked us to find how much more time will it take for the car to reach the foot of the tower. So to travel this distance, let's suppose it took a time equal to t seconds. So if it's taking time is equal to t seconds, then BD, that is this length BD, will be is equal to again speed into time. Speed is u, time is t. So it is nothing but ut. So this is nothing but ut. I hope you are getting this. So all we did is we converted this distances into distance and time. So we took the speed as u. So this distance is nothing but speed into time. So because it took 6 seconds, so this distance will be 6 into u. Similarly, because it takes t seconds for it to cover this distance, so the distance for this BD will be equal to u into t. Okay. Now let's solve the problem. We have two triangles, that is ABD and ABC. Angles are given to be 30 and 60. Opposite side is h, and we have adjacent sides. So let's apply tan theta. So tan theta is equal to opposite by adjacent. So let's consider this triangle first, that is ABD. So ABD is tan 60 is equal to opposite side is h and adjacent side is ut. This is nothing but tan 60 is root 3 is equal to h by ut. So let's say h is equal to root 3 ut. So I just sent ut to the other side. So I got the value of h as root 3 ut. Now let's apply tan theta to this bigger triangle ABC. So you get tan 30 is equal to opposite, that is h, by adjacent. What is adjacent? ut plus 6u. Adjacent is nothing but ut plus 6u. So if I simplify this, tan 30 is nothing but 1 by root 3 is equal to h is nothing but root 3 ut. Why? Because we found the value of h from here, that is root 3 into ut. I substituted over here. H is root 3 into ut divided by, let me take u as common, that will be t plus 6. So this is nothing but u and u gets cancelled. So if I cross multiply, I'll get t plus 6 is equal to root 3 into root 3 is 3t. That implies 6 is equal to 3t minus t. So that is nothing but 2t is equal to 6 or t is equal to 3 seconds. So that's it. We found the time required for it to reach the foot of the tower, that is 3 seconds, because we assumed t to be the time taken for it to travel from D to B. Okay. So that's it. We found the value of t. Therefore, the time taken by the car to reach the foot of the tower from this point is 3 seconds. Okay. I hope this is very clear. In case you still have any doubts, please let me know. Thank you.